Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, I will introduce myself. My name is Andi Ahmad Raihan Akilah. I will talking about ISAS. What is the title is prime factorization. Today I will talking the prime factorization by two subtopic. The first is prime factorization, and the second is prime factorization algorithm. So here we go. What is the prime factorization? So the prime factorization is a number then is all of the prime number that multiply to create the original number. It would be pretty difficult to perform prime factorization if we didn't first refresh our memory on prime numbers. With that being said, a prime number is a number that can only be divided by one and itself. So I will give example a few prime numbers. First is 2, and second is 3, third is 5, fourth is 7, fifth is 11, and many more. So the conclusion is prime factorization is uh, the number that can only be divided by one and itself. Okay, we can go to the next step is prime factorization algorithm. We can see in this slide what is prime factorization algorithm. So I just uh, not talking too much. We can see in this slide what is prime factorization algorithm. Prime factorization is all of the prime number that multiply to create the original number. And then many algorithms have been defined for determining the prime factor of a given number. They vary quite a bit in sophistication and complexity. The simplest method of finding factor is so-called direct search factorization. In this method, all possible factors are systemically tested using trial division to see if they actually divide the given number. So maybe that's all from me. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Now, we discuss about prime factorization algorithm. Prime factorization algorithm is all of the prime number that multiply to create the original number. Prime number is a number that can only be divided by one and itself. Okay, in here we can see 13. I will give you example. 13 and 4. 13 is a prime number. Why? Because 13 has only two factors, itself and 1. 13 and 1. And 4. 4 is not number prime. It's not prime number. Why? Because 4 has three factors. It's 1, 2, and itself is 4. And the example I will give you a prime number in my note. Okay, and here I have a 20. The number of prime is 2, 3, 5, 6, 11, 13, and the others. All right, and 20 in here. I will 20 divided by 2 is 10. 10 is number of prime, yes or no? 10. In here we don't have 10. All right, okay, we continue. 10 divided by 2 is 5. 5 number of prime. Yes, 5. Oh, yes, 5. Okay, the result is 2 2 5. Okay, and the next is 24. 24 divided by 2 is 12. 12, we see again number of prime. We have 12, no, 11 and 13. We don't have 12. Okay, we continue. 12 divided by 2 is 6. 6, we see again number of prime. We have 6 or no, we don't have 6. Just only 5 and 7. Okay, we continue. 6 divided 2 is 3. We can see again. We have 3, yes or no? Okay, we have 3. Stop. We stop in here because we have 3. Alright? So the 2, 3, 2, 2, and 3. Alright? Maybe okay, thank you very much and keep watching.
Assalamualaikum warahmatullahi wabarakatuh. My name is Deni Otto Tehupuring from CCIT. Now I would like to discuss about the implementation of prime number factorization algorithm. It is implemented on a simple calculator as a prime number checker. And this is our source code for the implementation. This is the calculator and then the prime number checker. In the source code, the menu num1, num2, and ndi is an integer, op as a char, and prime equal to true as its boolean. So we can see here that this is the option where the user have to choose between 1, 2, or 3. The first option is the command calculator. So if this choose, then this code over there will be executed. And then also if the user choose 2, the prime number checker, then this piece of code will be executed too. And then if 3, then this will be executed then. Now we can see here this is the first menu, the first option of the menu, the command calculator, the second one, and the third one. So let's take a look here. What this piece of code do? This piece of code is we adopt the theory of the direct search factorization into this code. So in this code, we'll ask the user to enter or insert a number, a certain number, if they want to check if it's prime or not. And then the for loop here is used to do the checking in case that the number that the user enter is not a prime number or it is. So the for loop here too also initialize the value for I in here is equal to 2 and also increase its value for every iteration. So let's say in case the user insert a number that can be divided by the I and its value of I, the code will set prime into false, which will execute this one. So the output will be n, or the number that the user enter is not a prime number. But if the opposite, that the number cannot be divided, then the number is prime, like how we see over here. Now let's try to run this program. So this is the option where the user have to choose between 1, 2, or 3. Now let's choose 2, prime number checker. Now I want to put a number here. Let's see that put that obvious is not a prime number. Let's see it. if it's correct or not. Prime number is not a prime number. It's 9. 9 is not a prime number because it can be divided by 3. Let's see. Prime is not a prime. It's not a prime number. Then if we execute again, run it again, then we choose 2, enter a number. Let's see that obvious it is a prime number. And obvious is the prime number is 5. Then let's execute 5. 5 is a prime number. So I think this is from us. If there is offending and unpleasant action or words that come from our mouth, we deeply apologize. And thank you for watching. Have a great day.